Welcome to ShubhCode. This is episode 3 of the LWC interview question series. Today's topic, LWC wire versus imperative apex, which one and why? The data fetching questions that prove you know LWC performance. These are real questions from real Salesforce interviews. Let's get straight into it. Here is what we're covering today. How does the @wired decorator work under the hood? Then, wired property versus wired function, when to use which. Then, how and when do you use refreshApex? Then, what causes unnecessary re-renders and how do you prevent them? Then, what is the shadow DOM and how does it affect styling? Pay close attention to the last one, it's a follow-up question that even experienced developers get wrong. Let me explain this simply. In LWC, you can get data from Apex two ways: @wire or imperative. @wire is reactive, it automatically provisions data when parameters change and caches it heavily for performance. Imperative Apex is a one-time call you control, like a button click. Interviewers want to know that you default to @wire for reads, and only use imperative when you absolutely must control the timing.
What if I need to change data after getting it from @wire?
This is the deep dive wire question. Most candidates can use @wire but can't explain how it actually works. Here's the answer. The @wire decorator is a reactive service. It connects your component to a data source, usually an Apex method or a LDS wire adapter. When you decorate a property or function with @wire, the framework calls the wire adapter and provisions data to your component. The critical word is reactive. If any of the parameters you pass to the @wire adapter change, the wire service automatically re-invokes the adapter and your component gets fresh data. This is why @wire is called reactive data binding. The data flows in one direction, from the wire adapter to your component. You never push data back through the wire. The wire adapter returns an object with two properties, data and error. Both start as undefined. When the Apex call succeeds, data is populated and error is undefined. When it fails, error is populated and data is undefined. This distinction trips up developers who've only seen one pattern in their projects. Wired property. You decorate a class property directly with @wire. The framework assigns the result to that property. It's the simpler syntax and works great for read-only display scenarios. Wired function, you decorate a method with @wire. The framework calls that method every time new data arrives, passing the result as a parameter. This gives you the chance to process the data before storing it, for example, flattening a nested object, computing derived values, or transforming API response fields. The key difference is that the wired function approach gives you a chance to manipulate the data before it hits the template. And, when you need to call refreshApex to force a fresh fetch from the server, refreshApex requires you to store the entire wired result, so the wired function pattern is mandatory if you want to use refreshApex. This is the performance interview question and it's increasingly common at senior level. LWC re-renders a component whenever a reactive property changes. Reactive properties are those decorated with @track, or in modern LWC, any property that is an object or array, since those are tracked by default. 3 common causes of unnecessary re-renders. First, mutating an object property instead of reassigning the whole object. LWC tracks object mutations, so changing obj.name triggers a re-render. If you're doing this 10 times in a loop, that's 10 re-renders. Solution: build the updated object separately, then assign it all at once. Second, set state style patterns that update multiple tracked properties separately. Each update triggers a re-render. Use a single update to a combined object instead. Third, unnecessary use of @track on primitive values. Primitives are already reactive without @track in modern LWC, you're adding decorator overhead for no benefit. The Shadow DOM question reveals whether a developer truly understands the architecture of LWC. LWC uses a synthetic Shadow DOM, a JavaScript-based implementation of the browser's native Shadow DOM specification. The Shadow DOM creates a boundary around each component. CSS defined inside a component does not leak out to the page. CSS from the page does not penetrate into the component. This is component style isolation. It's a huge benefit for building reusable components. Your component looks the same regardless of what page it's placed on. The implication for styling: you cannot use standard CSS class selectors to style elements inside a child component from the parent. You need to use CSS custom properties, CSS variables, to pass styling values across the shadow boundary. The parent defines a CSS variable, the child consumes it. Let's wrap up. Here are the answers that will make you stand out in your next LWC interview. At wire is reactive data binding, parameter changes trigger automatic refetch wired function, not property, is required, when using refreshApex prevent re-renders, build updated objects outside loops, assign once shadow DOM equals style isolation, CSS does not cross component boundaries cross-boundary styling uses CSS custom properties. CSS variables practice these patterns in a Scratch org so they come naturally in an interview. Like and subscribe for a new LWC question every single day. Next up, Episode 4, LWC Security, User Permissions, and the questions about Locker Service. See you tomorrow.